Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is maximum height, and it is a hard level problem. So in this particular problem, it says that you have a garden with n flowers lined up in a row, and the height of the ith flower is AI units. Right now, we have to water them for k days, and like when you water any of those flower for one day, its height increases by 1, and you have to water w continuous flowers at once, right? So this is the problem statement. Now after a long time, I believe I found an interesting problem on Geeks for Geeks problem of the day. It uses a mix of different techniques and concepts, so that is why I found this problem interesting. And let me just start with the example test case that has been given to us in the input. So for this particular test case, the output is coming out to be 2. Let us discuss how it can be 2. Right. So the value of n is 6. That means we have 6 flowers. The value of k is 2. That means we have to water all the flowers for 2 days. And the value of w is 3. That means at any instance we can or we have to water 3 continuous flowers. Right. For example, if 2, 2, 2, 2, 1, 1. These are the flowers. Right. So if the value of w is 3, so you can water these 3 or these 3 or these 3 or these 3, right? It's just that they have to be continuous. So this is our problem statement. Now how can we form the answer to? If you carefully see, if you water the last 3 plants, it will become 2, 2, 2, 3, 2, 2. So this will be the flower's height after watering the last 3 plants for the first day. Now you have 1 day left, and again you can choose any sub array of 3 plants and you can water them, right? But the problem is, no matter whichever you choose, the minimum height will always remain 2. If you choose these 3, this will become 3, 3, 3. The first 4 will become 3 and this will become 2, 2. So the minimum will be 2, right? If you choose the last 3, this will become 4, this will become 3, 3. But the first 3 will remain 2. First 3 will remain 2, right? So no matter which of the flowers you choose, the flowers would be, minimum height would be 2 only. So how do we solve this particular problem? So like whenever we read such questions where we have to find the minimum value or the maximum value or maximum value questions, a very general thought that comes to our mind is binary search, right? Whenever we think of binary search, the first other aspect of binary search that we have to think is basically the checker function, right? So for any question, if we are able to form the checker function and we have to find the minimum value or maximum value, we can definitely use binary search, right? So in this case, we will use binary search. It's just that we have to discuss how do we form the checker function. But before that, let us discuss how are we actually going to implement binary search. So for binary search, I always recommend a technique called invariance technique. Let me just explain it very quickly. This is very important and this will help you doing binary search in many other problems as well, right? So how do we do this invariance technique? In the invariance technique, so for example, whenever you do binary search or answer, your answer is always like, our answer array is always like this, or your answer array is always like this, right? I hope you're getting what I'm trying to say from this particular thing. Whenever we do binary search, we know that our value will be either true for the first few values and then it will become false for the next values, right? And the other case can be the value is false for the first few values and it will become true for the rest of the values, right? So this is the basic like condition for binary search on answer. Whenever we do binary search on answer, our question must satisfy this particular condition, right? Any of those. So our question in this case is satisfying the first condition, where the minimum height or the minimum possible height is true for the first few values and some of the heights can never be attained, so for them the value is false, right? So we have to maintain an invariance. Invariance means that in this case, since our lower end is true, so we will always maintain that we have two pointers, right? Low and high. So we have to maintain that this particular pointer is always true and this particular pointer is always false. And we have to maintain this invariance at the end. And while after we have like finished everything, we can just return this low. So the benefit of this invariance technique is you don't have to maintain any answer variable. And you will further see that you don't even have to like think of whether you should do mid plus one or mid minus one or anything, any sort of that thing. The general format will be the exact same, right? So this is the benefit of using the invariance technique. I'll show you in a while how. So since our low is always true, we will do a while loop, a general while loop. While low is less than high minus one, we calculate the mid as it is. Let's say there is some thing to calculate the mid. Now if I just implement my checker function here, if this checker function returns true, that means for the current value of mid, my my condition is satisfied. So what I'll do is I'll assign mid to low, because low always stores the true value, right? If it is not able to satisfy the condition, I'll assign mid to high, because high always stores the false value, right? So the general function would be the exact same. Now you don't have to think of whether you have to do mid minus one, mid plus one, or any sort of that thing. And at the end, since low is always true, at the end you have to return low. If this was the case when high was always true, in that particular case you would have to return high. So this is the only part you have to think. You don't have to think about any other thing. So I just wanted to share this technique because this is very important and it helps you avoid mistakes in binary search, right? So this is the invariance technique. Now I've just explained it very quickly, and there is also one more topic I will have to discuss for this particular question, and we have already discussed this particular topic before, so I'll just quickly go through it. Now, how do we implement the checker function, right? The important part is implementing the checker function. A basic idea would be to like go through from the starting. For example, the value of mid, let's say, is 3, right? So if we want to make the value of all these plants, or the height of all these plants, at least 3, right? So for this particular plant, I will have to water it for 1 day, right? If I water this particular plant for 1 day, the height of the other two plants, since the value of W is 3, so the height of the other two plants that are contiguous to it will also increase by 1, right? So I'll also have to store this information somewhere. Otherwise, when I come to the second plant, I see that the value is 2, but actually its value should be 3, right? So I'll have to store this particular information somewhere. So one way to do this is segment trees, obviously, but we will try to avoid using segment trees, just because the first thing is code is very lengthy. The second thing is here we are doing range updates and point queries, right? So segment trees are generally useful when we have range queries, but since we have range updates and point queries, it is not very like ideal to use segment trees. So we will use a technique from dynamic programming, which I have already discussed before in detail. If you go back a little, the problem of the day was update queries on 1st of March. The exact same technique was used in that particular problem. If you don't know what the technique is, you can watch that video first and you will get a brief idea, because in that particular video I've explained that concept in very detail, like how do we derive the exact answer. So we are going to use the exact same technique. I highly recommend you to watch that particular video first, because it is very useful. And let me reiterate, it was on 1st of March and the problem name was update queries. You can find it on my playlist. You will find it there. So here we maintain two arrays or two vectors, start and end, and with the help of these vectors we just try to find out what are the values present at any particular index, right? Let me just write the formula very quickly. So dp of I, so you can name this vector anything. So dp of I will store the value at any particular index. So for example, if you have updated here once and you have increased the height of this once and this once, right? So the height of this will be 3 and this will be, it should be 4, right? Similarly, now even if you don't increase the height of this particular tree by any amount, it should be 4, right? So the difference is 2. So our dp of I will store 2, that we have 2 pending updates, or the height of this tree looks 2, but it should be increased by 2 more and its actual height should be 4, right? So dp of I will actually store the pending updates or the change in height, right? So the formula to calculate dp of I will be dp of I minus 1 plus start of I minus end of I minus 1. So this is the formula that we derived in that particular video. Now I've just like written it, and if you check out that video, you will find this particular formula in great detail. How do we exactly derive this formula? But for solving the problem, you just need to know that this formula exists, right? So when we know this particular thing, now how do we find the answers? So let me just write this down. Now, when you update any of the trees, you can update the start and the end vectors. For example, the value of W was 3. That means you have to take 3 contiguous elements. Now, for example, if I update the first index, so I'll update start of first by, for example, I need 3 values, or let me just take the variable need. So I'll update the value by this much, right? Because I need this amount of height extra, right? And the end will be updated by I. Let me just take the variable I here, I plus W minus 1. Why? Because if the value of W is 3, if I add 3 to it, so it will be 1, 2, 3. It will get to this particular position. But the contiguous elements are 3 here. So I need to do minus 1. So that is why it goes to this particular position. Right. There is one more thing that we need to take care of. For example, if I am at this particular position, now if I add 3, or if I add 2 to it, that is I plus W minus 1. If W is 3, then I'll have to add 2 to it. So it will go to this particular position which is out of bounds, right? So the ideal way of solving this problem should be to include this particular contiguous array, right? But it will just like unnecessarily increase the complexity of our code. So what we actually do is, like, how do we implement this? Before doing this particular thing, we just perform a neat trick where we just consider this particular subarray. Actually, the length of the subarray should be 3, but we only take 2 because this would have already been computed, right? So for example, if I wanted to make the height of all the trees 3, so let us say this is already 3, like, and I want to increase the height of these two trees. Now, even if I take this particular 3 and increase, so for example, to make these two 3, I'll have to increase it by 2, right? So if I include this also, I'll have to increase this also by 2. This will become 5. But this element becoming 5 have no like effect on me because the minimum height is still 3, and I don't have to care about this particular element, whatever its height becomes, as long as it is above 3, right? So increasing its height does not make very sense. Like, even if you increase its height, this does not make any difference to you. So what we'll do is, to like just make our code simpler, we'll just avoid data limit, right? So if you are at any index after which you cannot move further, for example, you wanted to take 3 elements from here, but you can only take 2, so it's just better to take 2 elements, right? So what we'll do is, we'll take the minimum of this thing and n minus 1, right? So the only difference from like update queries questions and this particular question is that in that particular question, the start and the end arrays were already pre-computed for us, and in this particular question, we are computing the start and the end arrays while traversing through the array, right? We are constantly trying to update them and find out the next values. So how will our checker function actually work? We have discussed all the things in detail, how we will store this particular update information for range updates and point queries, right? So we will be using the start and end array. Now the question is, how do we actually go about increasing the values? So for example, if I am at this particular position 2, I see that if I want to make them 3, so I need to increase it by 1, right? So my start of I will increase by 1. So start of I, or in this case start of 0, will increase by 1, and end of I plus W minus 1 comma minimum of n minus 1. So the minimum of these two values will also be incremented by 1, right? So I'll have to update the start and the end values, because now a range will start from here and it will end here, right? So I have to update the start and end of these two positions. Now dp of I would be computed accordingly, and then I'll just update the values. So the idea is to start from the initial pointer or the initial location and just go on them one by one and increase the current element according to our needs. If I don't have to increase it, I don't increase it. If I have to increase it, I just increase it by the corresponding value, and I update the start and the end array accordingly, so that all the elements in this particular in that particular range have the information that they have also been updated, right? I just need this information to further calculate. Like as I've already explained, if I wanted to make the first element 3, I would have made it 3, right? But the other two elements would have also become 3 at the same time. So this particular information will be stored in the DP array, right? They will not reflect in the original array, but this particular information that they have been increased by 1 will be stored in the DP array, right? So that the next time when I come to this particular position, I see that it is 2, but the DP array indicates me that it has been already increased by 1, so its value should be 3. Now I don't need to increase it further, right? This particular information we will derive from DP array, and we just keep on going through the loop. And as I've already explained, whenever we see that we have a subarray of size less than 2 remaining, we just ignore the first element before it, and we just try to increase the length of this particular subarray of remaining length, right? So there are actually two important concepts that are being used here, that is binary search, and the second one is range updates and point queries, right? So I've given you one overview of this particular method of maintaining the start and the end vectors. I've discussed it in detail in the first March POTD, and I've also discussed this invariance technique in very detail in today's video. So I believe, but still, if you guys want me to make videos on these random topics which are generally used, like binary search, this range update, point queries topic, and something like DSU or any other techniques that are being used in solving problems, then you can tell me in the comments. I'll be making some videos. We'll just maintain some series kind of thing where we will discuss some random topics like these, and you can also like comment down your preferred language. We'll be making our videos in that particular language only. So the option is English and Hindi. We'll be choosing the language which has the majority of votes, right? So if you want us to make videos on some specific topics, you can tell us in the comments. So now that this is done, let me just very quickly go through the solution. So the solution is to use binary search. I've already discussed the invariance technique, how we will maintain the invariance between the low and the high end of the range, right? Now, how do we implement the checker function? To implement the checker functions, we need to use this particular thing called range updates and point queries. We can also use segment trees, but we decide to use the more simpler approach using DP, that is by maintaining the start and the end vectors, right? This is the second important thing. The third important thing is when we have a subarray of length less than the size of W remaining, we can just ignore the initial elements and just focus on the remaining elements, right? So this is the third thing that we need to discuss. And at each position, the idea is to, at each position, I just check if the current element is less than mid, I want to increase it by that particular value, and I'll also update the information in start and the end vectors. So this is the whole key idea of this particular problem. Now let us quickly have a look at the code, then you will understand the problem better. So here is the initial function that is being called. So this is also important. Let me just discuss this quickly. Now, how do we actually go on deciding the low and the higher end of the ranges, right? So in this particular problem, it was not very important, but if you go on like more difficult binary search problems, the value of the range that you choose becomes very critical, because sometimes even on binary search it gives time limit exceeded because of how long the checker function is, right? So it is very important to decide the range of the low and the high after giving it a thought, not just some random values, right? So it is not very important in easier question, but it becomes important on more harder questions. So for example, in this particular case, when we decide the low, we can conveniently take low as the minimum element of the whole array, of the whole initial array, because even if I don't like water any of the plants for any of those, I know that the minimum height will still be to the minimum value of the initial array, right? Now talking about the highest value that we have to take. So for this particular value, we can choose, for example, the size of the array is 10 raised to the power 5, right? Each element can be 10 raised to the power 9, and at max you have to water them for 10 raised to the power 5 days. So each 10 raised to the power 9 of the plants will increase its height by 10 raised to the power 5, right? So the minimum height would be 10 raised to the power 9 plus 10 raised to the power 5. So we can take any value greater than 10 raised to the power 9, it should work. So that is why I have taken 10 raised to the power 10, right? So let me just quickly discuss the question. So here I have taken the minimum value as a low, and I have taken the highest 10 raised to the power 10 value as the highest. So exactly as I have stated in the explanation, I just take while low is less than high minus 1, I calculate the mid, I implement the checker function, and if the checker function returns true, I just set low as mid, otherwise I set high as mid, and at the end, after I'm out of the while loop, I just return low, right? So this would be the main solution. Now coming on to the checker function, this is very important. I just initialize three vectors. The first one is dp, the second one is start, and the third one is end. So all of them are initialized with 0. So for the first value, I have to compute it separately because there is no previous elements to it. So I need to compute it separately. Now if the a of 0th element is less than mid, right, that means I have to increase its height. So what I'll do is I'll just find out the height I need to increase. So this is the need, that is equal to mid minus a of 0. So if k is less than need itself, that means I cannot increase its height according to our needs. That is why I just directly return 0. Otherwise, what I do is I just subtract need from k, because I'll use that number of days, or I'll use that number of required amount from the value of k. So I need to subtract it, right? So start of 0 would be incremented by need, and end of w minus 1 would be incremented by need, right? Similarly, dp of 0 would be incremented by need. So this is just the basic stuff that we need to do. So after like starting from the first position till n minus 1th position, what I do is I just set dp of I is equals to dp of I minus 1 minus end of I. So if you carefully observe the formula that I have written here, you will see that dp of I is equals to dp of I minus 1 plus start of I. So this is very important. I have not written it right now, minus end of I minus 1. So the thing is, dp of I minus 1 is already computed, end of I minus 1 is already computed, but start of I has not been computed yet. That is why I have not included it in my answer right now, right? I just excluded for the time being. Now if a of I plus dp of I is less than mid, right, that means I have to include some additional value to my answer, and that additional value would be equals to start of I, right? So now I need to calculate the value of start of I, so that when I add it to dp of I, it becomes greater than or equal to mid, right? So a of I is the initial value, dp of I is a change I'm trying to make to the height of the plant. Now I just calculate the value that I need to increase, that will be equal to min minus a of I plus dp of I. So if k is less than need, then just at the previous time I return 0, otherwise I subtract need from k, and now I increment start of I by need. So when I increment start of I by need, so it will be added to dp of I, and then it will become equal to or greater than mid, right? Now similarly, as I have discussed, I'll take the minimum of I plus w minus 1 comma n minus 1, and I'll just add need to it at the end. After it, I just increment dp of I by need, and after this has all been computed, if I don't return 0 in between, that means I've successfully made the height of all the plants at least equal to the mid value. That is why I return 1. So this would be the solution for today's problem, max min height. I know this video is a bit long because the problem is I have to explain certain concepts in the video itself. That is why I was talking about, if you guys want that we make separate videos for these kind of concepts that are being used, so please tell us, and also tell us the preferred language. We'll be making videos in that particular language only. So I hope you guys were able to understand the solutions. If you guys did, then you can show the appreciation by dropping a like on this video. Also don't forget to subscribe to this channel, as like these videos are very helpful to some of the people. So don't forget to subscribe, and till the next video drops, keep coding, stay safe, bye bye.